Ropes and knots. Fire service is always dependent on ropes for hoisting equipment, gaining access, rescuing people, stabilizing equipment and vehicles. Types of rope. Life safety rope, used to support rescuers and victims. Must be constructed of block creel construction, of continuous filament virgin fiber without knots or splices in the yarns, ply yarns, strands or braids, or rope. Life safety rope must be used only for supporting people during rescue, firefighting, or other emergency operations, or during training. Manufacturers must supply information on use criteria, inspection procedures, and criteria on removing life safety rope from service, including not visibly damaged, no signs of abrasions or heat damage, has not been impact loaded from a sudden stop with a falling load, cannot be exposed to any chemicals, and must pass inspection by a qualified person before and after each use. Life safety ropes which fail in inspection or have been impact loaded must immediately be changed in one of these manners: altered so it cannot be mistaken for life safety rope and inadvertently used again, disposed of entirely, remove the manufacturer's label, cut into shorter lengths, or clearly marked as utility rope. Utility rope, for all uses except life safety, such as hoisting and securing items. No standards for utility line application. Fire escape rope, emergency self-rescue rope used to escape an immediately hazardous environment, not classified as a life safety rope. Must be destroyed after each use. A throw line, floating rope that is intended to be thrown to a person during water rescues or as a tether for rescuers entering the water. Rope materials, natural fibers, not acceptable for life safety ropes, can be used for utility purposes. Most natural fiber ropes are made of sisal, manila, or cotton. Some rope materials, natural fibers. The advantages: resistant to sunlight, does not melt when exposed to heat, and holds knots firmly. Some disadvantages: it's prone to mold and mildew, deteriorates with chemical exposure, and it burns. Rope materials, synthetic fibers, used for life safety applications. Excellent resistance to mildew and rotting, excellent strength and easy to maintain, may have continuous fibers running the entire rope length. Synthetic materials commonly used: nylon, polyethylene, Kevlar aramid, polyester, polypropylene, and spectropyethylene. Kern mantle, jacketed rope, constructed of a braided covering or sheath, the mantle, over a core or kern of the main load-bearing strands. The core runs parallel to the covering, increasing its strength. The kern accounts for about 75% of the rope's strength. The mantle provides the rest of the rope's strength and protects the core from abrasion. Low-strength kern mantle is the most common rescue rope used. Rope construction, dynamic. It's designed to stretch without breaking. Used when long falls are a possibility. Not practical for rescue or hauling operations because of its elasticity. Static. It's designed for low stretch without breaking. Used for most rope rescue situations where falls are not likely. Must not elongate more than 10% when tested to a load equal to 10% of its breaking strength. Laid or twisted rope. Constructed by twisting yarns together to form strands. Most vulnerable to physical damage by abrasion because all load-bearing strands are exposed. Used most commonly as utility rope. Braided rope. Constructed by intertwining strands together, can be subject to direct abrasion and damage, and used as utility rope. Braid on braid, or double braided rope. Constructed with a braided core and braided jacket. It's considered strong due to each braid taking half the load. Does not resist abrasion as well as Kern mantle rope. Outer sheath may slide along the inner core. Factors affecting rope strength: knots, kinks, and bends, cuts and abrasions, chemical contact, sunlight and ultraviolet light, overloads, heat, mold and mildew for natural fiber, and moisture. Rope inspection. Inspect all ropes after each use and annually. Follow the manufacturer's recommendations. Label or identify all rope. Keep a maintenance log. And inspect ropes visually and by touch. Inspect all ropes for foreign materials, cuts and abrasions, chemical damage, or heat damage. Kern mantle inspection. The damage may not be obvious. Put a slight tension on the rope and feel for lumps, depressions, or soft spots. Outer sheath damage may indicate inner core damage. The core can be damaged without visible damage to the sheath. Check for irregularities in the shape or the weave, foul smells, discoloration from chemicals, roughness and abrasions, excessive fuzziness. If there is any doubt about a Kern mantle rope's integrity, it should be downgraded to utility rope status. Synthetic or laid rope inspection. Check externally and untwist and check internally for soft, crusty, stiff, or brittle spots, cuts, nicks, or abrasions, chemical damage, dirt or grease. Natural fiber rope inspection. Check for ruptured fibers, dark spots indicating mold or mildew, brittle or ruptured fibers that may indicate chemical damage, rust spots, heavy grease, or oil stains. Braided rope inspection. Check for nicks, cuts, heat damage, and unusual fuzziness. Feel for mushy spots and deformities. Braid on braid rope inspection. Check for sheath sliding on the core, and feel for lumps that indicate core damage. Removing rope from service. Chemical contamination, age, uneven diameter or texture, excessive sheath wear, life safety rope which has been subjected to impact loads or overloaded. Caring for rope. Avoid abrasion and wear caused by dragging over rough, gritty surfaces, vibrations against compartment surfaces, compressed into tight spaces, Avoid sharp bends and angles which can reduce strength up to 50%. Protect the ends from damage and unraveling. Never subject a rope to sustained loads for more than 2 days. Never exceed the load limits. Avoid rust. Prevent contact with chemicals, oils, paints, solvents, or cleaning compounds. Uncoil a rope which has not been used for a long time and recoil it with the locations of the ends changed. Do not walk on rope, which can grind dirt into the strands and bruise strands under compression. Cleaning rope. Natural fiber. Do not use water. Wipe or gently brush. Synthetic fibers. Follow the manufacturer's directions. Clean with cool water and mild soap, and avoid bleach and harsh detergents. Dry all ropes thoroughly and out of direct sunlight. Maintain a rope log. New rescue rope should be marked on the ends with an identification number and the date in service. A log should be kept throughout the rope's life. The dates of each use and inspection should be entered into the rope log. Record any incident of impact loading. Rescue rope should be stored in clean, dry spaces with adequate ventilation. Rope should not be exposed to chemical contaminants or fumes. It should not be stored with gasoline, powered tools, or fuel. Rope bags. Best for storing life safety ropes. Rope can quickly deployed by holding the rope end and throwing or dropping the bag. The rope's weight carries the bag towards the target as the rope plays out. Knots, kinks, and bends should be removed when storing rope. Coiled rope must be capable of being placed in service with a minimum of delay. Improperly coiled rope may tangle and fail to uncoil. Webbing. Used with rope for both life safety and utility use. Webbing may be of solid flat design or a tubular design. Most webbing is made from the same materials as synthetic rope. 1-inch webbing is the most common webbing used. Webbing uses: to support firefighters during operations as a rescue harness or ladder belt. To construct technical rescue anchor systems. To package and secure victims. To attach rescue components together. A Class 1 harness. Fastens around the waist and around the thighs or under the buttocks. Intended for emergency escape for up to 300 pounds. Class 2 harness. Fastens exactly like a Class 1 harness, but is rated for up to 600 pounds. A Class 3 rescue harness, or full body harness. Fastens around the waist, under the thighs, or under the buttocks, and over the shoulders, and is rated for up to 600 pounds. Utility webbing. Used for securing hose rolls and bundles, raising and lowering equipment, as part of a search line system, securing doors open, carrying hose and equipment, controlling an inward swinging door, pulling a victim out of a hazardous area, or securing a vehicle roof or door during extrication. Many firefighters carry a section of utility webbing in their turnout gear for use during emergency operation. Long lengths of webbing may be rolled or daisy-chained for storage. Life safety harnesses should be kept in bags for protection. Knots are used to connect ropes or webbing, form loops, and attach ropes or webbing or objects. Improperly tied knots are hazardous to rescuers and victims. The running part, free end used for hoisting and pulling. The working end is used to form the knot and tie to the object. And the standing part, between the running and working end. All knots should be dressed after being tied, tightened until snug with no slack. Knots can sometimes loosen or fail from repeated loading and unloading. A safety knot should be tied in the tail of the working end to prevent slippage. A fire service knot must be easy to tie and untie and be secure under a load. A rope's strength is reduced to the degree it is bent. The tighter the bend, the more strength is lost, and some knots create tighter bends. Knots are formed using these bends. A bight is formed by bending the rope back on itself while keeping the sides parallel. A loop, made by crossing the side of the bight over the standing part. And a round turn, further bending the sides of the loop. An overhand safety knot, used for added safety with any knot. It eliminates the danger of ends slipping back through the knot. A bowline, one of the most important fire service knots. It will not constrict the object it is placed around. It is easily untied. A half hitch, always used in conjunction with other knots, used to stabilize tall objects being hoisted. It's formed by making a round turn around an object. The rope's standing part passed under the round turn on the side opposite the intended direction of the pull. Several half hitches can be applied in succession if required. The clove hitch consists of two half hitches, used to attach rope to poles, posts, hose, and to hoist round objects. Not suitable for life safety uses. Can be formed anywhere in a rope. Can withstand a steady pull in either direction without slipping. Should be backed with an overhand safety knot. A handcuff rescue knot consists of two adjustable loops formed from a bight, used to secure a victim's hands or feet to raise or drag them to safety. Adjustable until the half hitches are tightened. Figure 8, the foundation for the group of figure eights. Can be used as a stopper knot, so a rope will not pass through the grommet of a rope bag or a rescue puller. A figure 8 bend, also known as the Flemish bend, used on life safety rope to tie ropes of equal diameter together. A figure 8 on a bight, used to tie a closed loop in the end of a rope, tied by forming a bight at each end of a rope and then tying a simple figure 8 with the bight in the double part of the rope. A figure 8 follow-through is used to secure a rope around an object. A single figure 8 is tied, and then the end of the rope is wrapped around an object and follows back through the single figure 8. A becket or sheet bend, used for joining two ropes of unequal diameters or joining a rope with a chain. It is unlikely to slip with wet rope and is not suitable for safety work. A water knot, the preferred knot for joining two pieces of webbing or the ends of one piece when a loop is needed. Numerous hardware items are used with ropes and webbing, primarily in rope rescue. A carabiner, a metal snap link used to connect elements of a rescue system together. A figure 8 plate or descender, used for rappelling or as a friction brake in lowering systems. A brake bar rack or descender, used for rappelling or as a friction brake. An ascender, used to ascend a vertical rope. Pulleys, used in rescue systems to change the direction of pull or create a mechanical advantage. The most common use of ropes is to raise or lower tools and equipment from one level to another. Pressurized cylinders such as SCBA bottles or fire extinguishers should not be hoisted by rope. A tagline or guideline should be tied to the piece of equipment to prevent the equipment from contacting the building when being raised. Hoisting safety. Always have a solid footing. Use hand over hand to keep control of the rope. Protect rope from sharp edges with an edge roller or padding. And work in teams for firefighter safety. Make sure area is clear of personnel and electrical hazards. If hoisting a charged hose line, secure nozzles from accidentally opening. Always remember to use a tagline to control the object. Pike poles. Clove hitch is placed near the end of the handle with a half hitch near the middle and another half hitch around the head. The pike pole should be hoisted with the head upward. Hoisting an axe. A clove hitch is tied near the axe head, and the working end of the rope is looped around the head and back of the handle. A half hitch is tied on the handle a few inches above the clove hitch. A second half hitch is tied near the end of the handle. Hoisting a ground ladder. A bowline or a figure 8 on a bight is tied and slipped through the first two rungs of the ladder. After pulling the loop through, slip it over the top of the ladder. Hoisting a dry hose line. Fold the nozzle end of the hose line back over the rest of the hose for about 4 feet. Tie a clove hitch and an overhand safety knot over the nozzle and the hose it is against. Secure the doubled end with a half hitch about 12 inches from the loop end. Hoisting a charged hose line. Tie a clove hitch and an overhand safety knot around the hose about 1 foot below the nozzle. Tie a half hitch through the nozzle handle and nozzle to allow the rope to hold the nozzle shut. Other fire service uses for rope. Control zone perimeter. Utility rope can be used to establish a perimeter to control access. Clove hitches with half hitch overhand safety knots are used to tie rope to trees or posts. Search lines. Using ropes as search lines can help firefighters working in smoke-filled spaces. Branch lines tied to a main search line will allow firefighters to search larger areas while staying in contact with the rest of the team. Object stabilization. Webbing and utility rope are frequently used to stabilize objects, such as preventing a vehicle from falling after an accident. When using rope to stabilize an object, personnel must be sure that the anchor point is strong enough to hold the object's weight, the knots are tight and safety knots are used, attachment points at both ends are secure, and everyone is clear of the line in case it breaks. Rope is one of the oldest tools in the fire service. Ropes are used to stabilize vehicles and equipment, hoist and lower equipment, and rescue victims. Firefighters must be proficient in quickly and correctly tying the appropriate knot for the task for their safety.